Okay, we should be recording. So from the survey that I gave everyone, it looks like a good amount of people at least know something about Rhino, but there's also a good amount of people that have never touched the software before. So we're going to go through a very simple overview of, the commands that will be useful in this course. Clearly, by the looks of the screen, there's a lot of other commands that we're probably not even going to be able to touch during this semester. But if you're really interested in this topic, you can really easily go and figure out what all these other buttons do and how they work and do your own research. But for today's class, we're just doing very simple things. So right here on the left, I have the Rhino interface, and this should be what shows up when you first open Rhino. It's probably going to look more like this with the 4 different screens. So we have a top view, front view, right view. And then the one I like the most is perspective, because we can see all the different angles of our design at once instead of just one of them. So to get back to that screen, what you can do is double click on that button that says perspective, and you can get that screen. If you want a different one, you can double click on that too, and you can get that. But these, be warned, are locked to this one perspective. So we're going to go to the perspective view here. And all the key clicks and things should be popping up on the bottom right of the screen, which is something I've added new to this semester. So yeah, hopefully that's helpful for everyone as well watching this back. Okay, so for moving around the screen, right now I'm cheating and you can't see why, but I have a special mouse to move like this in Rhino. But to go back to the keystrokes, because this is what everyone else is going to have, moving around in Rhino is very simple. It's mainly just your mouse and the shift button. So right now, if you right click in the canvas, you'll be moving around the screen, and this little orbit icon will come up as well. So that'll allow you to orbit. Basically what I mean is like view around in 3D. The next one would be panning, so kind of scrolling left and right. If you can see in the bottom right as well, but if you hold shift and right click, we'll be panning around the screen. So if we combine those two, we can orbit and move to traverse our scene a little bit better. And then the last one, zooming, that's just the middle mouse wheel, so we can come in and out pretty simply. If anyone can get this to work or isn't able to follow along, let me know now so we can figure out any issues. And I'll just give you a minute there. I wonder if I can turn down some of these. Okay, so if everyone seems to be good, we'll move on to some of the basic modeling topics in Rhino. So the first one, the simplest, is adding points to the scene. So this is the main toolbar up here, and this toolbar will change if you change the tabs up at the top. Mainly if you go to different modeling tools like Solid or SubD. And these are all what they say is the most used commands, so it's probably the most important panel to cover. But we're just going to focus on standard for today. And this has all the basic things that you'll need to interact from Rhino to Grasshopper. So if you click on any of the ones here, the first one we'll click on is point. You can see we have a point in the scene that we can place. There's also a little arrow at the bottom of most of these icons here. And if we click on that, we can see there's a range of other options as well. And this is the same with the polyline, or the curve. There's a lot of different options here. So you're not just limited to the basic elements that it gives you here. So the first one with the point, if we left click on this, we can bring this into the scene. And if we left click, we can set that down. And you'll see with the mouse click too, that little orange circle is left click and a blue circle is right click. And that shows up something else that is important. If you right click in Rhino, it'll redo your last command. And if you've been noticing up here, every time we do something, we get a new command that pops up in this little list. So we can left click to place down a point again, and we can either go select it, or to redo the command, if we right click, it'll bring back up what we just did and we can set another one. So that's basics of points right now. And this is placing it on this XY grid at the bottom here. You'll see these points have placed kind of randomly on the grid here. They're not really lined up. If you wanted to line it up, And we have these other options at the bottom. So grid snap, ortho, plano, gumball, all these things. If we turn on grid snap right now and we go redo that point command, you see we have a point again. Now it's locking to this grid structure on the floor. So it only allows us to place on the grid, which might be helpful if you find that necessary. And we can turn it off again. Another thing is if you turn this on and it's not snapping to a point on the grid or a point on a model, we have these other options down here, which are all helping to control where things snap to. So if you've opened up Rhino for the first time, these may all be unchecked, but right now I have my favorite ones checked, which are just end, which would be an end point of a line or just a point. Near to things, the midpoint, the vertex of a mesh, things like that. So you can customize this to what you feel is most useful. But right now, this is what I have. So if we do that, it'll be snapping to these points on the grid. So I'm gonna go ahead and turn that off right now. The next one that we'll cover is the curves up here. So we have a couple different curves: control point curve, interpolate curve. In terms of curves, the one I think is the most accurate is this interpolate one. The reason I say this is because the curve will go through all of the points you set. With this first curve here that is here by default, you can see if we place a point down with left click, it'll have this line. And if we keep placing, it'll try to fit a curve as best it can through these points. So if you hit escape, it'll delete the progress. If you hit enter, it'll finish it. And we have a line here. So that's different from the point. The point, there was nothing else that you had to do. But for anything more complicated, you do have to click enter to finish that off. We'll look at the interpolate as well. And this one I think is more accurate because it follows the points that we place down. So you can see this curve is now going through the points. So this just allows me to be a little bit more accurate when I'm placing these curves. And you'll see with the text line up here, every time we do something, it's going to list something like I said. But now that we're doing some more complex things in a point, it also asks us some questions here. And you can see it's also prompting us for what should be next. And this is really helpful if you're stuck in Rhino and don't know why something isn't working. You can usually look up to this line up here, and it'll be prompting you for the next thing that it expects. So right now we want to do the next point, and we press enter when done. So it's really helpful that it kind of gives us some tips as we're designing to help us along. So right now we have an open curve and some points. Another thing we can do is finish off a curve and make a closed curve. So if we go and finish off by clicking that first point that we set, it'll make it closed and it'll add a smooth transition for the line there. One of the next things we can do is, instead of just curves, we can actually draw shapes. So just like if you were in Photoshop or Illustrator, you can draw circles and squares and a few other things too. Some polygons here, but we'll just simply do a rectangle for now just to show. And just 2 points, you can set that. You'll notice also all these are being set on the XY plane. And that's one thing with Rhino right now, since we have this plane set up, anything we click in the scene is gonna go onto the plane. It'll also go onto the plane even if it's infinitely far away. So if we place this, it's gonna be, looks like it might be near everything else on the scene, but if we zoom out, we can see it's really far away. So just some things to be careful about when you're modeling. Another thing to, what I just did was do a box selection to select something. So if you left click and drag, it'll pull up a selection window. You can also click the object. With selecting though, if you, special things with the selection box, if you start from the right side and go towards the left, this will select anything that the box touches. But if I do the opposite and go from left to right, this will only select things that are all the way included. So right now, this selects nothing. But if I were to completely include the rectangle and the point, but not that closed curve, you can see it'll only select those two and leave this one out. So it is very specific on how that box selection works, but that's the only two functions of it. The next thing we'll do is one of these 3D shapes. So I pulled out the box here, or the cube, And this one is set, again, just like the rectangle, with the rectangle on the floor. And then you'll see it'll be prompting us in the top for the height. So we can move our mouse up and that'll give us some height. You also see at the very bottom of the screen here, it's reading out some measurements. And this is really helpful too. When you load up Rhino, you do have a certain unit associated with the scene. Right now, I'm in small objects millimeter scene. You'll see if you ever go to create a new file, it'll ask you what units you want to use, if that's feet, inches, centimeters, millimeters, things like that. So right now I've set that height and the command is finished. So you see the line is blank and we have a box. Right now, this box is transparent, which the only reason that is because if we drop down here, we can see we have different render views. So as I said earlier, double clicking the perspective will go back to different scenes like this, but hitting the drop down also gives us some more options. All the things with moving around, setting views, setting cameras, but the ones we'll be using mostly are these two shading options here, wireframe and shaded. So right now we're in wireframe, so nothing will have faces to it, nothing will look solid. But if we go to shaded, you'll see it'll add faces to this box, and now it is no longer transparent. It is a solid box. And that has all to do with the shading options. Even though it looked transparent, it was not actually lines. It's actually a box. And this box is a special one. It's called a B-rep, or boundary representation. It's a specific type of geometry that was invented by McNeil, the creators of Rhino, a while ago. And that basically means this is more of a scalable type of vector representation of this box. So there's a mathematical equation defining the box, and if you make it a lot bigger, the detail will stay there. It's very similar to like SVGs in Illustrator and the Adobe products versus a raster image or a image made up of pixels. And if we wanted to relate those two, if you had a mesh object, let me see. Yeah, so I guess I'll just explain. It's too much to pull it out, but right now I have a B-rep of a box. If I had a mesh of a box, I could scale that mesh up, but the polygons that make up the mesh are going to stay how they are. So the detail is going to get lower the bigger you make it. With this box, we can scale it up as much as we want, and that detail is always going to stay there. So just very specifics of types of geometry in Rhino, and that's going to come into play more as we get into Grasshopper, because it is very specific on what types of data that you give it. So just a little explanation there. We'll get into that more later in future classes as we go down the line. Okay, a few more things. I'll touch on surfaces now, and surfaces are also different than B-reps or meshes. And one simple one here we can do in this surface tab is create one with 3 or 4 points. So you see as we finish that, it'll fill in the middle. And now we have just a flat surface in our scene, and we can make it any shape we want. With these two, it's just a very specific data type. But one thing that I'll touch on now is if you want to edit these shapes after you've placed them in the scene, one thing we can do is with that surface selected, if we come down to this button here to show the control points on a surface, we can turn that on, toggle it on. You'll see it'll give you some tips here. And once that happens, we have these points that come up, and we can move these points around our scene to edit that surface. So now you see the surface is not just a 2D rectangle, and it's also not a mesh face that only has 2 polygons that make up a rectangle. This is now calculating the curvature as you move across this surface. And I'll update as we move these points along. So if we go back here, you'll see this is giving us some points, and it's showing with the left mouse click, it'll show them, and with the right mouse click, it'll turn those points off. So I have the surface select again, I'll hit the right mouse button, and those points will go away. And now we cannot select the corners anymore. And the last one I'll touch on here, and this is if you have Rhino 7. If anyone has Rhino 6, it doesn't have sub-D tools, but for those who have Rhino 7, we do have this option for sub-D geometry. And one thing that are very interesting about these, and we won't touch on them huge throughout the course because I know not everyone has Rhino 7, but just to show the possibility, because it will be useful to some people, is this box, as it was here, sub-D box, is created exactly the same as a BREP box, but you can see this one is visually different and the functionality of it is a lot different too. It's very smooth. What sub-D stands for is subdivision. So what it's doing is it's taking this box, which is made up of, as you can see, 8 smaller boxes in it, if we did the top and the bottom, and it's smoothing out with an equation, smoothing out that surface so we get this smooth box. But one thing that's super powerful about sub-Ds is you can almost sculpt with them in a 3D software. So with this sub-D, we have the same power that we did with this surface with the control points, but in this case, we can select anything. We can select a face, a line, or a point, and move that, and it'll update the box. So this is a super basic introduction. So, if you don't remember everything, that's totally fine. But just to show you, with this, it's special. There's not a button to turn on control points, but what we can do with this sub-D in Rhino 7 is with Control, Shift, and left clicking on a spot. So right now I selected this line. We can pull that, and you can see the geometry is updating, but updating in a very smooth manner. So we can do that to anything that was a line. We could do it to a face. So Control, Shift, left click. I'm not sure why the little icon isn't showing like Control, Shift, but it is Control, Shift, and left click all at the same time. And you can select a part or multiple parts if you hold down Control, Shift, and click multiple times. And that'll allow us to affect the geometry more. So that was a super basic introduction into using Rhino. If anyone has any questions about that or couldn't get something to work, let me know. And anytime I can stop and talk, but if not, we'll go ahead and move into basic introduction to Grasshopper. And this is a little bit more in-depth than in Rhino. We're not using Rhino for traditional modeling purposes hugely in this course. We'll mainly be doing the computational design stuff in Grasshopper. Okay, so with Grasshopper over here, I put down this little simple interface as well to explain how Grasshopper works. So in this interface, if we are left clicking, we can select anything in the scene. The scroll wheel will allow us to zoom in and out. Right click, as you see, will move the canvas around. Left clicking and drag will do the box select. So again, this is going to work the same way as it did in Rhino. If we move from the right to the left, it'll select a scene. Left to right is only selecting things that we overlap. As you can see, it only selects the interface, but not the list of text below it. Next one here, double left click. So if we double left click in the scene, it'll bring up the search bar. This search bar is used heavily in Grasshopper. It's the main way that we can pull up different commands that we can use in Grasshopper. So with this bar, we can type in anything and it'll do a search on all the components that we have installed and give us some of the best results. So once you find the one you want, in this case, a simple line, we can pull that in and it'll give us that component here. So we'll get into the theory of Grasshopper in a second, but just for the interface of Grasshopper, that's how the search bar works. And self-explanatory, if you hit delete, it'll delete anything. So this next one here, Control Alt left click. This one's pretty nice. Even people that may have used Grasshopper for a while might not know about this one. But if you ever have a component and you don't know where it came from, and we'll get into all this up here in a second. But if you hold Control Alt and left click on a component, you'll see that these arrows that I assure you comes stock with Grasshopper pop up, and it'll tell you where to find that component. To some people, it might look like a weird plugin, but that's just how it looks like. And that's super nice. It'll show you where to find it up in this list up here. So to explain what all that is, we have the ribbon tabs and the component sections and the plugins. So that's everything that just popped up here. At the top, we have the ribbon tab, which has all of the different commands that we can use in Grasshopper. So very similar to Rhino, where the commands are over here on the top. In Grasshopper, they're over here. So Grasshopper itself is what I would like to call like creative coding software. So it is coding in the sense where you're stringing different commands together with an input to affect an output. But in this case, it's all visual based, and we can see a lot better of what's happening. A lot of architects have more visual skills, so this is a super nice way to interact with software. And as you'll see as we go on, the way you actually use Grasshopper is very visual as well, with how these components fit together and the things you can do with them. So the next one, the component sections. So if you select any of these ribbon tabs, and for most people that have Grasshopper, it'll only go up to display here. I'll get into what the rest is in a second, but for these tabs, these should be what you have. And if you're in a tab and you come down to the sections of the components here, you can drop down and you can see everything that's in this case, the display dimensions tab. We can do the similar one for mesh. So we come to mesh triangulation. There's a lot more commands here than what it shows in a little preview. And if you have a smaller screen than me, it might even show even less in the preview up here. Like some of these, this one only shows 8 different options, but there's a lot more below it. So always good to click these drop downs and see what's in here. Another nice thing about Grasshopper compared to other coding softwares is that it really gives descriptions for every single command that you have access to here. So if you hover over one, in this case, insert items, we can see that this one will insert a collection of items into a list. So we can click that, left click it, and it'll come with our control or our mouse pointer into the canvas. And if we left click again, it'll set it down. So now that we have it down, you can see this is what the component itself looks like. It has some inputs and it has some outputs. And with this one too, if you don't know what this does, you can hover over any of these inputs or the outputs, and it'll tell you what it wants, what it's asking for. Very similar to Rhino, where if you start a command, the command will prompt you on what it wants, what it needs, or what are the different functions of it. Very similarly here, you can come and pull up any component and hover over either the inputs, the component itself, which is the icon in the middle, or the output, and it'll tell you what it does. And one thing I just realized here, also, if you've opened Rhino or Grasshopper for the first time, you're probably not seeing what I'm seeing. You're probably seeing the components with little titles like this in the middle. For some people, they might like that, seeing the words here so you can see what it is. But as this is a visual coding software, I'm going to keep it as a visual coding software. So if you come up into display, you can draw the icons and it'll show the actual picture of the component here. One thing too, because people always ask me about this, is they would like to still see what it says so they can search for it and place it in the scene, which you'll have to remind me to do for next class, but there is a way to get the component name and the picture here. But for today's class, we don't need it too heavily, but I'll have that for next time so we can follow along easier. And the last part here, the plugins. So everything after display I have as a plugin, and this was installed after I got Rhino for the first time. So these contain a lot more components that you can use in conjunction with the stock components of Grasshopper to do different things in your scene. So one of the main ones here I'll just touch on for a second is Kangaroo. And what this plugin gives you, in addition to the modeling capabilities, of Rhino. What Kangaroo offers is a physics-based simulation that you can add on top of this. So you could take, say, a simple surface like the one we have here in Rhino, maybe give it some tension on the points and simulate a surface that could be showing the forces of an arch or something, and allow you to calculate things like that. That would be very hard to almost impossible to simulate in Rhino itself stock. So there's a lot more that do a lot of other really cool things, but we'll touch on those later in the course. For most of the other classes, we'll be focusing on different plugins so we can see the power of everything that Grasshopper offers. So you can take this back to either your classes, your studies, or just your personal interests and be able to use this how you would like. In this class, we're covering very specific things in terms of body architecture. It's just a really simple way to show what these commands can do on a small scale. But a lot of the things I will touch on in this class can be applied to a range of different areas: industrial design, architecture, automobiles, structural analysis, FEA, a bunch of different things. So really powerful. But after the main interface of Grasshopper is explained, hopefully that makes sense to some people. If not, ask me questions in the Discord right now, whatever, all works. But we'll move into the theory of Grasshopper and try to understand basically how everything works together. So now we should know how to search for components and bring them up. So we can search for anything and bring it into the scene here. So I brought in these components already to have this little diagram together. And for the main aspect of how the creative coding goes on, the visual programming goes on in Grasshopper, is everything is flowing from left to right, which makes a lot of sense in the Western world, I guess. But in this, always moving from left to right. So right now I have an input. It could be anything. It could be a number. It could be a piece of geometry. It could be artificial intelligence, whatever you want to plug in comes in. It goes through another component, which can make some effect on the input. In this case, we have a move component. You can see it's describing what it's doing. It's translating whatever object you place in. So it'll move that, and then we get an output from that too. So you'll see we have the input, which is this green outline cube here, and it's moved, and it ends up over here. So that's a super basic theory of how this works. And we'll move on to some other ways. So when you're looking at a Grasshopper script, you always want to follow these lines of connection from everything. So this one does the same thing as the one we just saw, but in this case, this component, the output, is to the left of everything else. The code is still moving from left to right, but you just have to follow the wires. So we have an input going into the move component, and then you'll see this line comes out, but then goes back to this one. And this is the final output, that box that has been moved along a vector. So this is still totally fine, still moving left to right, but sometimes it could be confusing visually, especially if you have a lot going on in a scene. There could be many wires overlapping. So just to show that this is how it works. Another one here, this would be a loop, which is one thing you can't do. And you'll see we get a very clear visual error here. So if anything ever goes wrong in the scene, usually, hopefully, we're seeing really good components like this that have like a silvery gray color. But if there's ever an issue, you might get an orange or a red component, and that's telling you that something's wrong. In this case, what we can see is we have an input, goes to the move again, and then comes to an output. But at this point, the output is plugged into the input, which creates an infinite loop, which is something Grasshopper does not like. So coming from other programming softwares, you might be super familiar and use loops a lot, like a while loop or something, which is super powerful in other softwares. In Grasshopper, it doesn't like it too much. There are plugins like Anemone that get around this issue, and you can do looping functions. But in main stock Grasshopper, it's not something that it likes. You can see the components red. Also, a bubble will pop up right here that'll show you what the error is. So if there's ever an error, a little bubble will come up. And if you click on it, it'll tell you what that error is. So the debugging is instant in Grasshopper, no matter how big your canvas is with other components. And you can see that we see that cyclical data is detected. So it turned off that component so you don't run into any issues of it crashing. So pretty helpful there. And the last part here for the theory of how the components work is a lot of components have multiple inputs and multiple outputs. So you can do a lot of things at once with a component. So this one, again, same thing, is it's moving the box that we have in the scene. This time it's moving it up instead of to the right. The only difference here is we're using, as with this move component, moving along a vector, the vector is now a z vector, so unit z. In Rhino, z is always up. That might be different from other programs you used where y could be up, but in Rhino, z is always going vertical. And in this case, it's going up 5 units. So you see we have the box as the input, but we also have a move as an input. So this component, the move component, is one of the more basic ones. It only has a couple inputs, outputs. And this one, the input geometry, the second input is the vector of how to move it. And this is very similar if you were in Rhino and you had a box and you wanted to move it. We have that same command here, the move. This is going to move from point to point, which is similar but not the same as a vector. A vector is a point to a point with a direction, but is comparing it from Rhino to Grasshopper right now. And you'll see if we watch the command up here, if we click this command, it's same as using a move component in Grasshopper. You want to select the object to move. In this case, we've selected a cube. In Rhino, I'll select a cube. Press enter. Where we want to move from. So in this case, it's a unitized vector of 5. So it always starts from the origin point. Right now, I could start from this point on the box and then point to move to. I could move it over here. And it's moved that box. Same thing here. And I could even move it in a very similar direction. So instead of Z, I could move it in X, and you'll see we move this box from the start where it was over to the left a little bit. So same thing that I did with this box, just in Grasshopper. So going back to kind of what I said at the very beginning of class, with these design tools, we're using a lot of the commands that you would use in a normal CAD software. So I don't think it should be more scary than another CAD software, even though we are programming. We can use all the same commands like this move, very simple. And we can do everything that we would do in Rhino, but now we're just doing it with code that's all strung together like this. So the nice thing I think about doing it this way is the way we did it in Rhino is we moved this box, we moved it by hand. It was super simple. We clicked 2 buttons, it was moved. But now if we want to move it again or move it back, we have to do all those steps over again. So if that step was like 5 clicks of clicking, moving point to point, I have to do that every time if I want to make a change. In here, if I want to make a change, the command is already set up. So all we would have to do is say change, the number in here, and now it'll move it different amounts. So that command's already set up, and we can just plug in a different input and get a completely different output. So with that quote of computational design that I showed in the presentation at the very beginning, this is the power of Grasshopper, the power of adding a computational parametric script, some code to our CAD software, is being able to do commands that could be very complex, but just with a simple input change. This is clearly a very simple script that just moves something. But if we were working on a script, that say calculates how a facade could be held up by a structure, and you want to change how the facade looks, you don't have to remodel the whole structure. You can just change the facade, update the input, and you can write a very complex program that figures out how to update the structure underneath. And that can all be done in one click instead of having to spend weeks remodeling. So that's really the power there between what we're going to cover in this class and what's possible with Grasshopper. So as I move forward from some of the really the basic theory of Grasshopper, the components, how they work, I wanted to move into some other really important theory about Grasshopper itself, and that is how lists and, more importantly, data are treated in Grasshopper. And quickly, we're just gonna, another Rhino tip here, we're gonna hide all these inputs for a second. One thing in Rhino, just hopping back to Rhino for a second, is we have these different layers, just like Photoshop or Illustrator, we have different layers, and we can move things to layers and hide those layers. So right now I just wanna hide everything I did, because I don't want it getting in the way of our view of Grasshopper. So I don't like all these here, so I'm just gonna make a new one and just have it as the place to hide everything. I can right click here, and with all these objects selected, I can change their layer. Now, if we click the little light bulb, they'll all be hidden, so we can just hide them there for a second. So now I have a really nice view of what's happening in Grasshopper. And it's always nice, also, I feel, to have Grasshopper and Rhino open right next to each other, because in Grasshopper, we can't really see what's happening unless we have Rhino open, so we can see what's popping up. And another little thing I'll mention here is right now, I usually always keep mine to draw or to preview what I'm selecting in Grasshopper. If you're opening Grasshopper for the first time, it's probably not like that. It's probably showing everything in your scene. And I guess that's one thing I didn't cover with the interface, but it'll show everything that's popped up in your scene. And I have a lot of stuff open right now, some of the stuff we've been covering. So it's going to show everything that is a component in your scene. But quick thing about the components too, with the right clicking that I mentioned earlier, with the menu that comes up, if you right click on a component, you have 3 simple options here for most components. And we have preview, enable, and bake. Right now, if we're previewing, that'll turn on and off the view of a scene. And just to show you really simply. So if we have this box in the scene with all these buttons turned off, you'll see if I don't click on it, it's red. If I do click on it, it's green. So selected is green, not selected is red. If I were to right click this and turn off preview, you'll see nothing will be in the scene, even if we click on it. Since we turned off the preview, it's not there. So you can function that way, or you can function with the only drawing it when you select it turned on, which is this green cylinder. So even though it's not selected right now, if I click it, it'll come up, but only the one thing you're clicking will come up. So if you have a big scene with a lot of things you want to see, this might not be the best option for you, but right now, just for showing a simple workflow, I'm going to only preview the stuff that I click on. So just simply to show how that works right there. Also, another little tip, you might not like red and green for your previews. Really simple to fix that. Right next to the green cylinder, we have this orange and white sphere. If we pull that up, now we have a list of any color you want. So, we can change the selection color super easy on the fly. So now if we have it previewed on, it's red, select is now dark green instead of light green. So super simple. I'm going to hop back into here and only preview what we're looking at. Okay, so with the list theory, it's very important to understand how data is maintained in Grasshopper, as that's the main thing we'll be focusing on in this course, is having the right inputs going where they should be, and organizing everything correctly so that the code we make is clean and organized and understandable and works efficiently and everything like that. So with this one right now, what we have is a construct point. So what this does is it adds a point to the scene. You can see this point exists at 0, 0, 0 because there's a 0 in X, Y, and Z. As this component comes, it's always 0. It'll be at the origin right there. For this next one, you can see that we have all these points coming up here. The reason it's doing that is because every point has an X value of 5. And we can see with this little icon down here, it shows X, Y, and Z and how they're orientated in this scene. You can also see with the grid, we have a solid red and green line. So that's seeing positive X and positive Y. So with a positive 5 here, we have the points moved 1, 2, 3, 4, 5 units over in the grid. And they're also spaced out in the Y-axis as well, because we have a series of numbers from 0 to 9 going into Y. So we have a point at 0, point at 1, all the way up to 9. So we have 1 point and we have 10 points here. So if I were to connect them with a line, so what this line is doing is drawing a point from A to B. So A is a single point, B is these 10 points. So it's going to draw a line from that 1 point all the way to each one of these other points up here. And with these two lists, we can see in Grasshopper why this is happening too. I mean, with the list, it's a very important tool in Grasshopper just to visualize like what's happening to the data itself. We can see in Rhino geometry and curves, but if we want to see the data and how it's getting affected, we can only see that in Grasshopper itself. So with these panels, it's important to know, where it is. In the input, it's right here. Or super simple, if you're searching, if you put in 2 slashes, you can get that panel and you can plug things in and see the data inside of it. So super helpful to have that component, but I'll get into more about components later on. Okay, so we have the line connecting point to point. And we can see that it's taking 0, 0, 0 and connecting it to each one of these points here. In this list, we have indexes of each point of data. So this first point at 0, 0, 0 has an index of 0. In Grasshopper, we always start counting at 0 and go up. We never start counting at 1. We always start counting at 0. So this list has 10 numbers, but the last one is going to be 9. So just to keep in mind, usually that's how programming works too. So important to know that. But yeah, this one has 10 indexes, 0 to 9. We can see the index here, and then the point itself visualized as 3 numbers, X, Y, Z coordinates here. So getting a little bit more complex with how the lists work. Now we have 10 points on the origin axis and 10 points 5 units away on the X. So if we were to take these and connect them by a line, you see now instead of this fan, we're getting this kind of ladder effect here with these lines. And we can see why that's happening if we look at the panels here and see how the data is coming in. So we can see with these 2 lists that have 10 items, what Grasshopper does and how it works is it's going to take this first index and connect it to the same index in the next list. So 0 index is connecting to 0 index, and that's going to be this line down here. The next one, as we move up 1 unit on the y-axis, we'll have this one connecting to this one, and we get the next rung in the ladder, and so on, all the way up the list. Other important thing with these 2 notes I have here, and it's going to become important in the next one, is in addition to the indexes for each point of data, there's also a branch that is kind of the folder for the whole group of everything in this list. In these 2, it's pretty simple. We only have a single branch, and right now that's just going to be branch 0. So in the same way that it's going to connect index 0 to index 0, it's also going to connect branch 0 to the other branch 0. This one, it's simple since we only have 1 branch in each. There's no special things that are happening yet. So 0 to 0, 1 to 1. That's how this works right now. Okay, the next one gets a little bit more complex, but we're really only changing one thing to get the lines to go from a ladder to this web structure right here. I also want to point out in Grasshopper, you can get really complex visual things really quickly. And we can see this, it has 5 components, and we're getting a really complex looking pattern right now. So I'll explain why this is happening too. We can see a couple things are different with this one. The main thing that's different is we have this little up arrow here, upwards pointing arrow. So usually with right-clicking a component, we see these 3 options, but if we right-click on an input or an output, there's a couple different things that come up. The main thing is this list right here: reverse, flatten, graft, simplify, or an expression. We'll pretty much only focus on flatten or graft. You can probably figure out what reverse does. It just flips data, super simple. Flatten and graft don't make as much sense. So right now, if I ungraft that, you see we have this ladder again. But if I go back and I graft it, what this is doing is it's putting each piece of data on its own branch. So as I said in the last example, we had a single branch at 0, but now we have a branch for each piece of data. So we had 10 pieces of data, we're going to have 10 branches. So we have branch 0 all the way up to branch 9 right there. And each one of those contains a single point from this list of points. So what it's doing now with this line system is it's taking point 0 and it's going to connect it to the other branch. And in this case, since there's only one thing in here, what Grasshopper does is it keeps going until it runs out of data to use. So right now it has point at 0, 0, 0. So that's going to go ahead and connect to the first point of this list, but it's also going to go ahead and keep running through this entire list until it finishes it. So it's going to connect the first point in this list to every point in this list, and back and forth until every point is connected to every other point in the other side. So if we break this down and just look at the very first point over here, we can see that it's connected to every other point on the other side, and so on and so forth. As we move up, we can see every point is connected to the other one. And that's just because point 0 is connecting to everything and point 1 is connecting to everything. So we have a huge list like that. This might not be super understandable at first, but as we move on with Grasshopper, we'll get really used to these things happening because a lot of different scripts utilize a lot of different graphs or flattens or functions like that. So I explained what graph does, and we can see when we graph something, we also have this dotted line that comes up to show that the data coming out is in multiple different branches. So flatten just does the opposite of graph, and it's going to combine every branch into a flat list again. So I can do both commands. They'll just cancel each other out. Right now we have graphed on, but if I also turn flatten on, you can see that we go back to a single branch at 0, and we have the ladder again. So they kind of override each other. But if you have a list with multiple branches, you can flatten it to get back to one that's more simple. Or if you want to go from simple to more branches, you can graft it and go like that. So simple explanation there. So you'll see this next one. Both of these lists of points are grafted. So both are in 10 different branches, but you'll see again, we get a single ladder of lines. So now what we're doing, we're getting back to what I mentioned earlier, where branch 0 connects to branch 0, as well as if you have data connecting, it's going to run through the entire list until it finishes. So in this case, we have 2 lists that each have 10 different branches. And in this case, we have the point at 0, 0, 0. In branch 0 will connect again to branch 0. So that point, which is down at the bottom here, this line gets connected over here at x equals 5. So we have that line, same thing for each other rung in this ladder. So branch 1 connected to branch 1, same like that. So this is exactly the same as when they were both flattened. So as I said, 2 graphs cancel each other out, or 2 flattens, graph and flatten cancel each other out. We're getting the same thing, the same visual output in Rhino, but the way the data is treated is a lot different now that we have all these branches. So this might be something you're looking for in your scripts. We'll definitely see later on how this can become more useful, not just a simple explanation, but for now, this is how this is happening. Okay, so to explain a little bit more how these lists are working in a more visual manner, I've introduced this component called the loft. And what loft does is it makes a surface out of some curve inputs. So if you have used other CAD softwares before, you know what lofting does. It makes a surface. It can be a very free-form surface or this flat rectangular surface. But we're using the same ladder of lines again. And what this loft is doing with this simple list that has one branch is it's taking line 0 and it's lofting to line 1, then again to line 2 and 3, until it gets all the way up to the last one, line 9, and it has one single continuous loft. Just like that. But if we get down here, we have the same lines, nothing changed in Rhino. but both of these are grafted now. So you'll see that now we have the same way as these are both grafted. We have the rungs of the ladder, but each line is now on its own separate branch, and we can see that in the panel here. See, each line is in its own branch. So if we're feeding that data into the loft, it works the same as I've explained in the past. Each branch is going to be run through until it runs out of pieces of data to act on. In this case, since there's only one line in each branch, you can't make a loft out of one line. You need to start and end to create that surface. So we can't loft one line to nothing. It'll just look like nothing in Rhino, and that's what's happening here. We have a loft that has no area to it. But showing how graph is still, useful in this case is now we actually have like 3D rungs of the ladder. So it's not just curves anymore, it's actual solid surfaces in Rhino. So right now, again, we have the two lists that are both grafted. So we have a line, each line on a separate list. But in this case, what I'm going to do is I'm going to add a second line into each list to actually give it some volume for this loft to start and end at. So if I take this line and using the move component that we looked at very early on of just a simple move, I can move this line up the y-axis by 1 unit or 0.2 units. And now we have a start and end line. So you can see that this would be the start one and this one would be the end one. But we want to have 10 different rungs. So we can't just have these all in the same list. They need to be in 10 separate lists. So we have 10 separate lofts. So what we can do with this component that I haven't explained yet, but we'll use it for this purpose, is inserting items. So as it says in the title, it's going to insert an item into a list. So we have this list of lines, which is visualized here. So there's one line in each branch. What we can do is take the other line, which if we view it in a panel here, is the same thing, one line in each branch. But if we insert branch 0 into the index of 1 right here, it'll insert the branch at 0 into this branch at 0, but now it's going to have the index of 1, which is higher than 0. So doing that, we can see we now have this branch of 0 and 1. So there's 2 lines in each branch now, still 10 branches, but now each one has 2 different lines in it. So now when we plug it into the loft, it'll run through each list until it runs out. So now we have 0 and 1. So it starts at 0, goes to 1, and does that for every single branch here. So now we have 10 different lofts, and we can see we've made these different rungs of the ladder. So, and we can, well, so this is one, kind of useful use of grafting and having different lists and how they're organized is with a very simple change to this structure. Like this was the simple structure. Adding a couple more components, we can have all these different rungs instead of just one simple loft like that. Yeah, so this can be very helpful. Instead of doing this part 10 different times, we could make 10 rungs like that. You could draw every single one, and you would have, 10 different copies and pastes like that to do all these rungs. That would be a lot of manual work, and that's what you would do in CAD traditionally. But since we have the power of the computer here, we can really take advantage of how these lists all work and organize the data in a way that the flow of the script is super simple, but we can do something really complex with how we structure it. So that's the basics of that. And I had this component here just to show that it's selecting index 0 of every list, which is every line, but also selecting index 1 will change it. And we can just visualize it like that in Rhino. So simple use of lists there just to show. So we're at 6 p.m. now. I'm going to keep going through super basic components so we have an understanding of what some components do before next Tuesday's class. But if anyone has questions on what I've gone through so far, let me know. We're still recording, so this will be on YouTube later. But yeah, we'll keep going into components and just showing how you find all these components now. So we know that we can double left click and search, but if you don't know what something is called, or you're unfamiliar with some components, this is not a really helpful way to do things. You could make something up and search for it, and you might find an answer. Like if we need a line that's pretty obvious, we'll probably find a line doing that. But if you want a more complex component, that's probably maybe not the best way to find something. So we'll go through where everything lives up in these tabs up at the top. So I touched on these earlier, but I didn't really explain what's in each one. And we're not going to do everything because there's a crazy number of components here, which hopefully you all understand at some point. You know, I've been doing this for a couple of years now, and you don't need to know every component, but it is nice to have a basic understanding of what's happening. Yeah, to Kyle's question, this file will be available right after class. So I have a Google Drive that has maybe 100 different Grasshopper files. It'll be everything and more that will go over this semester. That'll have a bunch of different scripts that you can see of how the workflows go together, different things you can make with Grasshopper. I'll be sharing all that after today's class to the people that are in Discord. I'll put a link there to that Google Drive so you can all see it. Yeah, so, okay, so going through some of these basics. So the first one here, the parameters, these are mostly just inputs. A few exceptions, like the panel that we showed, that you could use it as an input or an output, but for most of these are inputs. And we have really basic containers here in the geometry and the primitive section, which can all hold pieces of data that line up to their name. So some really simple ones, we have points that can hold a collection of points. We can hold a collection of curves, meshes, B-reps, sub-D, geometry. So as I said in the beginning of the class, you know, each thing you do in Rhino has a very specific data type. So meshes are different from sub-Ds. And that's shown here where you have different inputs for all those different file types. So it's important you keep those organized in your script and you know what you're using and you know where they go. So you don't run into any red components or errors in your script. The next one, some of these input sections. So these are mainly value inputs. Some of these, like the image sampler or the gradient, could be color or image inputs, but for the most part, these are all value inputs. So right now we have this integer value from 0 to 1. The slider is one of the most, I think, important like inputs if you're doing a number-based thing. So I'll go through like how they're set up. You can pull them in from up here. So we have a basic number slider. It'll come in as an integer with 3 decimal places from 0 to 1. But you can also go in, if you right-click on the slider, you can edit it. And you can change a lot about what's possible with the slider. The main thing is the minimum and max boundary domain of the slider. Right now it's 0 to 1, but we could also do, you know, 0 to 100. Hit enter, make that change permanent. And we could also go, instead of, you know, rational floating point numbers, to integers. And now there'll be no decimals, and you'll see we'll go up the integers from 0 to 100. So that's one way to edit them. Also, if you want to search for it, this might be something you'll look back in the recording later, but if you want to search for this, you don't search for a slider, you actually search for the domain of the slider. So you can customize the domain before you even have it in your scene. So super simple way to do this you could type in your first number, so the lower bound, put 2 periods, and then the upper bound, so say 0 to 10. So 0 is ... 10, hit enter, and you'll have a slider with integers that goes from 0 to 10. You can also do it a little bit differently. Say this time we want decimal places, but we also want to set what number the slider comes in at when you first put it into your scene. You'll notice the last slider started at 0 when we added it to the scene, but in this case, we could do 0, decimal 0, 0. So now this list is going to have 2 decimal places. We could add the less than symbol, so it's less than, say, 4, for example, which that number will be the number the slider will start at. And then we could add the upper domain, or the upper bound, which could be 12. So now we have these group of 3 numbers with less than signs in the middle. And you can make this whatever you want, but if we hit enter, you'll see it'll start at 4. It has 2 decimal places. The lower bound is 0, the upper bound is 12. So just 2 different ways you can add sliders in, or if it takes a little bit to get used to typing in all that, you can just pull it from the input and edit it after you have it in there. So the next one is the panel, which I've already shown how to search for with 2 slashes, but you can also grab it up here. This can be used, as I said, as an input or an output. If it's an output, you're connecting things to it, and you can see it'll update as you change what the script is doing. Or it can be an input as well. So copy and pasting here, say we have 2 different panels. We can double click in this panel to type things. So we can type an input, we can hit enter. Actually, good tip there. If you hit enter, it starts a new line. It doesn't confirm the input that you put in. So if you want to stop typing, just click out of it. And this input is now going to the next panel and showing the output, which is just some text that I wrote. So that's a nice way to have an input there. If you want to do multiple inputs, we can hit enter and go down and do multiple inputs. You'll notice now that all these are in integer 0. If you wanted these to be in different lines in the branch, what you can do is right click on this panel and just enable multi-line data. And that'll now put your inputs on separate lines every time you hit the return key on your keyboard. So now we have 3 different indexes here, 0 to 2. So just an important quirk of how the panels work. Next one, we have 2 buttons here. So we're still in the input section. We have button and Boolean toggle. These are really nice for reset buttons or enabling, disabling things. Having different digital inputs like 0, 1, false, and true. So with the toggle, if you double click on the button, it'll change that state from false to true. The button single click clicks the button. And you can see this is also giving a Boolean input. So we have false, we click it, it goes to true until we release the button, then it goes back to false. So that's not a consistent state. This one is a set state every time you change it, false to true. The next one here that I think is a nice input is the graph. So the graph here, we can control a lot of data at the same time. So I'm going to add another panel into here. I'll show what's coming out. So when you pull the graph into the scene, graph mapper, you'll see there will be no graph in there. What you have to do is once you pull it in, you can right click, go down to graph types, and there's a lot of different types here of graphs. So super simple one might be a Bezier curve that you can have in this graph. And then you can change these handles and it'll change kind of the data that's flowing through this. So if I add some values to it, I just have a range from 0 to 1 here with 11 values. And if we change the graph, you'll see it's remapping those numbers based on how I change this graph. So this is kind of a powerful input that you can use to affect a lot of data at the same time. So nice component there. The last one, which I've already done a lot and what we've seen in the past, is what Grasshopper calls a scribble, but what could also be called like a notation in your script. So if you ever want to leave notes for yourself or describe or annotate what's happening in your script, what you can do is grab the scribble component. It'll tell you what to do. You double click it and you can type in whatever you want. So once you have that, you can change the text size and just hit OK, and you'll see what you type will pop up there. So super nice. We can make it really big too. Just a good way to leave notes for yourself or leave notes for other people. It's always good to, describe what your script is doing. So yeah, with those basic inputs in the parameter section, we'll move on to the math section now. Just some simple things in the domain that I want to touch on is we have a construct domain. So a domain is a number to a number, in this case 0 to 1. So you can put those values in here and we'll get that domain coming out. Super nice. The next one, deconstruct. So if you have a domain and you want to get the start and end values of that, you can do that, and you'll see it'll just break down what we just did with the construct, just deconstructing it. The next one is the bounds. So if you have any list of numbers, you can see what the lower and higher bounds of that list are. So, we could take, for say, our graph data that we have and plug that in. And you'll see if we come out here, we'll see the domain is 0 to 1, which lines up with the input domain of 0 to 1. So the highest and lowest values are shown there. We could use this component that tests for inclusion. So if you have a list of data and a domain that you want to see if those values are within or not, we can test that here and get those output values. And we also have remapping, which works very similar to the graph that we just did, but we can plug in the values to remap, the original domain, and then the domain you want to change it to. So, say you're going from a 0 to 1 value to like an RGB value. You could take a 0 to 1 and remap that to 0 to 255 and change the data really easily that way. Moving over to some other stuff, we have math functions in here, which are all pretty self-explanatory. You have everything here: addition, division, multiplication. You can test for smaller than or larger than. We have and, or, nor gates, everything there. You could also, if you wanted to, write your own expressions here. So we're probably not going to use this much, but if you wanted to, you could go write your own math equation here. Might be easier than stringing a bunch of different components together. If you want to write that all out. Another thing we can do in this, we have some languages in Grasshopper. So we have C#, Python, and VB. So if you want to actually write code, you can do that too. And this works as C# or Python would always work. So we have that here. And you could write your own actual code to do stuff in Grasshopper, which is nice. So inputs and outputs, just like any other component, but the modifier inside this component is your own code. So that's pretty fun. Also, if anyone has used ChatGPT, you can use ChatGPT to write your own C# code and plug that in. Works just fine. So that's a cool thing. Yeah, so the next part, so trig, yeah. So one thing with Grasshopper, it uses a lot of radians for things like rotation or things. So if you want to convert from I like to use 0 to 360 as degrees, you can convert those to radians. Just a nice back and forth conversion here under the trig section. Couple other things, we have a average. You can test an average of a big group of numbers. We have pi, a lot of other stuff if you want to explore that section. Moving into sets, we looked at one of these earlier. I think it was the insert items. So insert items into a list. But this whole part is your list modifier section. So there's a lot here. Insert, pick an item out of a list, split the list, partition it. A lot of ways to break up lists or insert, remove things from lists in there. So that's all that stuff. Also ways to organize lists if you want to weave them or sift them. We'll get into how those work, or if you have any questions, let me know. But we'll probably use this little section a lot in some of the coming workflows. The next one, so sequence, we'll probably use this top part a good bit too. So we have things like we could delete items or cull them, like delete different indexes or patterns of indexes. Or with this one, we can create a pseudo random list of numbers. So if we give it a range, a number of random values, say maybe 5, we can get 5 random values from 0 to 1 out of that. So that's a nice one if you want to have some randomness to your script. Next one, so in sets, one that I use a lot is member index. So if you want to search for a specific item in an index, so you have a list of true false values and you want to find all the true values, that's a really nice one. So you can just find those indexes. And then in the text section here, pretty self-explanatory how this works. You're just modifying text here. We don't use this a lot, but it is maybe nice to know at least what concatenate does, which you can combine multiple text together into one final one. So with the, basic coding input here, if we combine hello to world, it'll combine that together into one text there. We add a space. So that's what concatenate does in the text section. In the tree section, so this is very similar to the lists, where these affect indices in a list, the tree will affect the branches in a list. So if you remember some of the list theory we were going over earlier, this will help you affect some of the branches. So one I used a lot earlier was the explode. So if we had a branch with a lot of things going on in it, like this one, we could explode it with this explode tree. And you can see this will break it up into only each single branch. So we can see we have branch, 002 here with 10 lines in it. So that's a good way to break up your tree. And then another one for this one, which I use probably mostly, if you have multiple things that you want to combine into one output, you can group them here. So if we had two pieces of data coming in, maybe we have this line coming in, and with any of these parameter inputs, if you right click on them, actually this is a bad one to use. We'll use curve for a curve. So if we right click on the curve, we can set that curve. Now you'll see it'll show up green. So we have that curve set. I'll set another one, and this time we'll go click on it. It'll set that curve. So now we have these two curves. If we want to combine them into a single data output, you see we have one curve coming in, and now we have a second curve coming in. So we have two curves. But I guess be warned, this is not grouping them together. They're just in the same list. There is a different component for grouping things. So those are different. Merge has to do with affecting lists. Group is different than that. So keep that in mind. Again, here, as I mentioned earlier, we can always affect it in the output. So we could graft it, two different branches like that, flatten it back down, and all that stuff. If I had a point, now you see we have a curve and a point. If I was to reverse it, point and then curve, pretty self-explanatory there. So that's what the merge does. So I use this a lot to just combine things together. So it's a really useful one. And that's the last thing we'll look at in tree right now. So going into vector, so we have simple things like grids, which is like this one that I showed. Simple grid there with different inputs if you want to change the size of it. One that I like to use, and we'll use this a lot next class, so next Tuesday, is the populate components under grid. So this one is populating a 2D plane. This one populates a 3D boundary. So a brep is the input for this one. And we can also populate geometry. So if we had a box, you'll see it'll populate only the outer surface of this box. So we'll use those a lot next class. So, keep these in mind for next class. Next one, so the planes, a lot of different things here. Saw different planes and how to affect them. Super simple. Ones at the top here are different unit planes in the scenes. Right now we have the XY, which is going to be the one we've been working with all day. And you can see it's defined by the X and the Y at the base here. But we could also maybe do YZ. And now you see it's on the Y down here in the Z axis going up like that. So super simple way to have the basic 3 directions in the scene as a plane. Next one for the points, also pretty simple. There's some other things here that are interesting, but we looked at this one, the construct point. We also have a deconstruct point. So if we set this point at 0, 0, 0, we can deconstruct it and get the values back out. So 0, 0, 0 for that. Also in here that I enjoy a lot is the finding the closest point. So if you have a point and a list of points, so we have, say, a point there and maybe the scattered list here. And what this will do is it'll find the closest point to the original in this list. And we'll use this a lot next class as well. So keep this one in mind too. For the last part in this section is the vectors. We looked at vectors for the moving component earlier. We were moving based on a vector, but we can also create them here. So we can create them with basic XYZ inputs. We could create it with a given direction and just add the factor. Or we could create a vector with 2 points, so a start and end point to make a vector, and then use that for a transform operation. Moving into the curves, a lot of different ways to analyze a curve. You can look into all these if you're interested. A couple simple useful ones is the curve middle. It'll find the middle of any curve. So if we pull in one of these curves, say this one, now we have a curve, plug it in. We can find whatever point is the middle of that line. So this is the same distance as that. For the next one, the endpoints, this will find the start and end points. So now we're seeing the curve and the 2 points. And then also, if we set a closed curve like this one, and it's not going to like this, I'll make a similar one. So you can see here, if we hover over the input, it's looking for a polyline, not a curve. So it's the reason why I said that I'll just imitate it with actual solid lines, just like that. So we have this polyline that we'll set. And now if we plug this in, you see we're getting 3 different centers. So we're getting the average of the vertices, the edges, and then the actual area centroid of that polyline. We can convert curves to polylines, and we'll touch on that right over here in a second. So the next one, so in division, there's a lot of different ways to break curves down if you want to get points out of them. So say for this curve right here, we could set this one. Now if we plug that into the divide curve component, this is the most simple one. It just divides the curve based on a certain number of segments. So right now we want 10 segments. So I believe we'll have 11 lines. Yep. And then I'll divide it evenly into 11 different segments with a point on each end. So that's what that one does. The next one. So there's a lot of different divisions that pretty much all do the same thing. Distance, length, you can have some different ways to divide it. But going down to this section, the perp frame. So this will add a frame. Same thing with the number. It's kind of hard to see, but it'll add a plane with the same directionality as the curve as it goes around this curve. So we have the 10 different planes there. Next one, line, super simple. 2 points creates a line. These are all in the primitive section now. A lot of different things here, but a couple simple ones, line, circle, rectangle. Super basic stuff right there. Next one in the spline section. So as earlier, when we were making our own interpolate curve, we can make one here with points. So, say we have this group of points. I'm just going to set multiple points this time. We have those points. If we plug them in, we'll get a curve that is very smooth through all those points. Interpolate. The next one is a polyline. It'll do the same thing, but now it's a rough line with kinks in it as it goes around. So smooth, not as smooth. With the next one, this could extend the end of a curve. Now we're into utilities. So we have a lot of different utilities here. Just a couple simple ones though. With this, if we have, say, a curve, we plug it in and give it a value to change by, we can add on to the start and the end of that curve just there. The next one, projecting. So as the name says, we could project a curve, onto a surface. So with this one, and just moving it around with the gumball in the scene, if that doesn't come up, you can just click this button down here and you'll get this gumball. You can move, rotate, scale, do all that. But what we can do is have a curve and a B-rep and a direction, and it'll take that curve and project it onto the surface right there. Pretty simple. And as I said, we can convert curves to polylines. So with this one, it's simply called that curve to polyline. So if we have that curve, which I think was one of these, we'll just take this. So we'll set this actual smooth curve into this one. And if we convert it to a polyline, you'll see it'll take, based on these other deviation tolerance inputs, it'll construct a polyline based on that smooth curve. So now we can plug this into the centroid one and find the centers like that. Okay, so moving on to surfaces now. So with this next one, we looked at earlier how you can deconstruct domains, you can deconstruct points. That's a trend. You can deconstruct pretty much any data type. This one's deconstructing B-reps. So if we have a B-rep, such as this box here, we can set that B-rep into Grasshopper, so it moves it from Rhino into Grasshopper. We have a box. And if we deconstruct it, now we can see all the vertices, we can see the faces, and we can see the edges all in a list here. So we've broken that all down. And we could just take one part out, and now we just have the vertices, or we just have the edges like that. The next one that is pretty useful in the analysis is the area here. This one used a lot by me to find a center of something. So if we have this 3D B-rep here, go back into wireframe, we can find that center point of that shape. So that's nice to have. Another one here, moving down to the bottom of this, is the point in B-rep. So this is an inclusion test again. So testing if a point is inside a B-rep. A little nice one. You can only use B-reps for this. You can't really find a point that's inside a mesh unless you have some plugins or something, but it's a nice one right there. And moving down to the very bottom, evaluate surface. So with a given surface, such as this one, and you can see when I'm typing in here, you don't have to complete the command to find the object. You could just type a couple letters and it usually pops up. So we could set that surface. And then this will find a point on the surface itself. So one thing I'm going to use here, just to get a U and a V kind of specific, we'll explain as we go on later in the class. But if you know about like rendering or texturing, UVs are important to you, but the surface is basically a two-dimensional plane. So to find a point on it, we're also using a two-dimensional input here. So you can see that based on the surface that we have. Let me just make a new one here. So you can see that with this input, we can select a point on the surface, and we'll also get a plane that is normal to where the point is on that surface. So you see it's changing as we move it around. So it's a nice way to find different values of a surface, kind of deconstruct a surface in that way. Another thing we can do, if you'll notice the point, it goes to that corner, but I cannot get it to the other opposite corner. Another little input here, if you right click, that hasn't shown up before, is reparameterize. So this will only show up with surfaces or curves, and it'll basically set the domain of that data type from 0 to 1. Right now, the domain would be from this point over here to this point over here. I don't know what they are, but they're not 0 to 1 because the point is not going from start to finish. So if we reparameterize, now you can see the point. Maybe I'll orientate it a little bit better. We'll go from that corner all the way back to this corner and see each one individually. So it's a nice way to find something out about a surface. Okay, moving on. So now we're in freeform. So as we constructed the surface in Rhino, we added 4 points to construct the surface. You could do the same thing with this component. just one of them in this section. We also have loft, which we looked at earlier. Again, we have sweep. If you use CAD before, you have these commands, lofting and sweeping. They're very similar commands. This one, boundary box, is more specific to Grasshopper. So if you have a piece of geometry like this surface, we can plug that into the input here, and you'll see we'll get a box that defines the 3D boundary of that surface, or whatever piece of geometry you stick into this. So now this is a really lightweight way to find out like the height, the area of a piece of geometry without having to do the calculation on the whole piece of geometry itself, which might be a heavier operation. This is a very simple way to just find out where things are in space, how big they are, things like that. And other commands that I've been using throughout this talk, we can create boxes, cones, cylinders, spheres. This is all in the primitive section. So you can really easily create the primitive shapes in Grasshopper. And these inputs here, you can change things like the radius, the length, the height of these different objects, and maybe with a number slider or something, change them to what you want them to be. Other one here, if you have Rhino 7, you'll have this sub D section. If you don't have Rhino 7, you won't. But one thing we can do with sub Ds is you can't really do a lot with sub Ds in Grasshopper until you convert them into meshes. So setting that sub D here, we can convert it into a mesh, and now we can use it for more things because meshes are very commonly used. And that's just in the sub D section here. Moving on to the utility section for the surfaces tab. This one, dividing the surface, very similar to this one, evaluating the surface. We can plug the surface in, and based on the inputs of the U and V, so 10 points on U, 10 sections on V, we can divide that into all these points. So that's a nice one. Capping holes. So this one, if you have B-reps, you'll notice that this cylinder does not have a top and bottom face. That's just how it comes in as, but if you want to fix that, we can easily cap that. And now it is a fully closed B-rep. There's no open holes in it. So this only works for B-reps, but it is a nice command to have. Another one, joining things. So if you have two B-reps, you can join them together into one B-rep. So that's nice of adding things together, but it's not a Boolean union. So there are differences there. Offsetting surface. So this is a nice one as well, still in the utility section, but if we have an input surface and we have an input here for the offset distance, we can offset that surface just like that with this one. So it's a nice little component. Okay, moving into meshes. As before with deconstructing things, we can also deconstruct meshes and find out things like the vertices, the colors, the normal values of a mesh. Nice thing to have. With meshes, we can also find the edges of that with this one. You see there's a lot in this section, but just covering a couple. Another one, finding the naked edge. So if there's an edge that's not connected to any other edges, we can find that out. So this is really helpful. If we have a hole in a mesh, we can find out where those holes are and draw a curve outline where that is. Moving on to the primitive section. Same as the primitive for the B-reps, we can have mesh primitives as well. So boxes, spheres, things like that. But this one, so this is a color. This is right up here, mesh color. So right now I have a very simple input box in the scene, and I've added colors based on this list here, one to each vertice. So you see there's 8 vertices of this box, and we've added a color to each one. So it's a nice component. Yeah, just a primitive box here. Very simple. Next one, so triangulation. A lot in this section up in the top here, we'll use also next class for Voronoi operations, finding cells and breaking things up. And that's these components here. We'll look at these next class. So I won't cover them right now, but I do like these two affecting different meshes. But just for time, we'll keep moving on. So utilities as well. So we can turn B-reps into mesh. We can add colors. We can join meshes together, same as joining VREPs. And then with meshes, we have the unique feature of having vertices. So we can also weld those vertices together, close creases or holes in a mesh, things like that. Moving into intersection, we can find places where objects intersect, and we also have our Boolean operations here as well. So we can find where lines intersect BREPs, we can find lines intersecting lines, BREPs intersecting BREPs, and get different answers of where all that's happening with these. We can also trim things with BREPs. So if we want to cut a curve into sections, we can do that with BREPs. Nice part here in the physical and the region section. We'll probably touch on some of these in the future as well, but just to know they're nice to have them there. I will look at this one quickly. So if we have one VREP like this box, we can set that in. But I can also duplicate this box here, maybe rotate it a little bit. So we have this VREP and the other VREP. I'll set both of them here. And now if we plug those two boxes in, see, now we're getting this curve that's finding the intersection. So just a nice thing to have. Okay, moving on to the shape. So Booleans, we won't touch on Booleans a lot in this class because they're very specific with Rhino and tend to break a lot. But if you want them, they're here. So you can Boolean union, which is actually merging the two objects together. You can cut them away, find where they intersect, and you can do that with region surfaces as well as meshes as well. So we have all those here. Then moving into these last two tabs. So this one, transforming, we have a scale factor with which can take an object and scale it up based on a factor there. So if we have this box, one will be no scale, and then anything lower or higher will change that. We also have projecting, so same as projecting a curve onto a BREP, we can project objects onto planes, get the outline from that. We have a mirroring function, so you can find how the object is mirrored. We'll just show that. So plugging this into the geometry, now you can see we have a mirrored answer to that. So one for both sides of this plane, and we can set the plane here as well. We have the move, which comes out of this section as well. So we can move things right there. And we can orient them. So this is moving with a plane factor as well. So you move from point to point, but you also move from a plane direction. So you can move as well as rotate the object at the same time. And then the last one, rotating. So you can rotate it based on a plane and an angle. So this is a one-dimensional rotation. And then moving on to display here. So display is nice to show things in Rhino. You know, we have ways to make colors here or deconstruct colors here. And we also have previewing materials or previewing vectors. So I'll take a look at these. So right now we could plug this color in, and we could also have our box. And I'm going to turn this back on to show everything mode. And we'll just preview off everything in the scene, except for this one. So right now we have the box, and we have a color value of RGB all 0, which is black. But we can add a value from 0 to 255 for RGB values, plug those into RGB. There's also an A value for transparency. And we can change the preview value color just like this. So if you want to have different objects previewing in your scene, but you want to have them show up as different colors in the scene instead of the same standard preview color, we can do that just like this. So now we can show two different colors at the same time. And you don't have to use color RGB We could use an easier one, just called color swatch. We looked at this back in the mesh section. Actually, this is an input, but we can plug this in as well. And this is a more user-friendly actual color value slider here where we can change hues and everything like that. So just two different options for setting colors right there. And then the last one I'll touch on today with the display vector section. So if we have a vector, say we'll set a vector with 2 points. Oh, no, not that one. Okay. So I'll just turn both of these off. So we have 1 point here, and we'll make another point, and we'll add a slider. I'll move this all over. We'll just put a slider in Y and X right now from 0 to 10. So now we have these 2 points, and we have a vector made out of them. But with the points off, we cannot see what the vector is, even if we're changing these values here. So that's where the vector display comes in, very useful. It has 2 inputs here, an anchor point and the vector. So we have the vector coming out, and the anchor point would be the starting point. So we'll just take A and plug that in. And you can see now it's giving us an arrow in the scene that'll show the vector itself. And this will show direction, strength of the vector. It's a nice way to visualize it. So if you're ever working with vectors, it's a nice thing to have so you can see exactly what the vector is doing. So you don't have to look at these values and figure out what they mean. 3,30 is pretty easy to understand, but if these are massive decimals or big values, it might be a little bit more confusing. So having this display in is very nice to have. But that's just a basic overview of some of the simple components in Grasshopper. There's a lot more plugins that we'll be covering in the future. Next week, we'll be going over Voronoi operations. So some of the things here, as well as the scattering, populating points, we'll be going over next class, looking at different cell patterns and attractor points. So that should be a pretty nice workflow. And we'll pull a lot of what we did today together into a bigger script that we can actually see some patterns being affected by our inputs and see how the power of computational design really comes in to constructing geometry. So yeah, that's everything I had today. This is recorded, so I'll post this later or tomorrow, and then I'll post a link to that Google Drive as well that has this, as well as every other Grasshopper workflow that we'll cover this semester, and some more in there available to everyone. And I'll put that in the Discord. So if you're not in the Discord, the link should be in the chat still up at the top. So make sure to join that. That's where I'll post everything and communicate with everyone. So yeah, thanks for coming to class today. I'll see you next week on Tuesday in Burchard 27, down in the back left of Burchard if you're coming down the big red stairs. So yeah, thanks everyone. See you then. If you have any questions, let me know.
Thank you.
Thank you.
Yeah, for graduate students, I'll talk to someone about that. I only have a Canvas right now for undergrads, so I'm not exactly sure how that works, but hopefully I have that figured out for next week.